I've been on this project for 18 months. We've got another 18 months to go to introduce new predictive models for mice to give the growers a heads up on what's happening out there. Trapping in September and December last year was very high in the trapping areas that I'm responsible for in Queensland and northern New South Wales. Breeding started early. Is it on? Yeah. Breeding started early in September, and after a fairly mild winter, we had a lot of females left over to add to the breeding population. So by December, they were really getting out of control, and all the females that I trapped were pregnant and or lactating, so they were putting 7 or 8 animals per female out into the breeding population every 3 weeks. There's very little activity in central Queensland and northern New South Wales, apart from a couple of isolated areas in the Dawson Valley that have put bait onto young sorghum. Research has shown that coordinated baiting with neighbours over a large area will reduce mice numbers quite adequately, reduces the re-invasion of paddocks and farms, and works out a fair bit cheaper to fly in bait over much larger areas rather than individual farms. At the moment, bait costs are running around about $9 a kilo, based on the retail cost of a 44-gallon drum of the stuff. And aerial application costs over a large area with multiple farms runs at about $9.50 a hectare, up to about $12 per hectare for single farms. Mice cause significant damage. Based on 2004 estimates, the national annual costs run at around about $36 million annually, and that's whether you've got a plague or not. And the costs cover crop damage, whether it's light or severe, loss of feed and fodder, contaminated grain, spread of disease through livestock or intensive livestock and humans, and damage to wiring and household and business products in a particularly savage year. Plagues are generally considered to be anything other than 500 mice per hectare, and at 1,000 mice per hectare they're virtually uncontrollable, and that's when they're pissing in your cornflakes and no amount of bait is going to change things. They occur in response to a range of environmental conditions, including rainfall, temperature regimes, weather, food supply, predation, disease, and social structure. They generally develop over 1 to 3 years, and all these environmental conditions that are favourable to a mice plague all have to fall into line to get a plague up and running. The peaks in population usually occur around about 4 to 6 months after maximum feed availability. The timing of the crash varies locally, but it's often due to disease, lack of food and lack of shelter. We can see here that the sandy soils around South Australia are really good for mice digging up seeds after they've been sown. These guys haven't even had a chance to germinate. There's tiller damage, chewed off there at the node or just above the node. They go for the moisture and the nutrients in the stem, which buggers the whole plant. You can see the damage where the heads have been chewed, seeds taken out, husks left on the ground. At this stage, stem and head damage is occurring. You often see white heads in the paddock, which some growers will think it's maturity, early maturing plants, but they're actually dead because the moisture and nutrients have been cut off, turning the heads white. Prior to flowering, one mouse will consume around about 50 heads per night to gain the nutrients and moisture they require. And at the doughy stage, they're reduced to about 1 head a night to get the same nutrients and moisture. As I said, they develop in response to a range of conditions. The Darling Downs model that you see here, that's the front page of our model program. That was developed in the 1990s, but has since become less reliable. It's around about 70% effective at the moment, and that's due to changes in cropping practices from conventional to conservation farming and the addition of a lot more crops into the rotation in the Darling Downs area where the model was developed to run. In the long-term prediction in June, which is this little button here. That trapping results give us the probability of an outbreak over the next 12 months. This one here, the midterm projection, gives you an idea of future mouse densities over the next few months, around about the next 5 months. And the short-term prediction based on trapping results in December will give us a prediction over the next 5 months into autumn on the downs, and that's covering the winter sowing period, which can be quite damaging if there's mice available. There's new models being developed on the current data that they used to develop this one in the 1990s, and the data sets that have been gathered over the years ever since that. We're using trapping percentages on a seasonal basis, crop type and yield, paddock management and farm management practices to build these better models. We've got various benchmark sites and quantitative sites set up all through the grain growing regions in Australia. Of interest here is the Darling Downs site, which is about 35k transect between Cecil Plains and Mount Tyson, which we trap every season. We use Longworth traps like these, or Elliott traps plus snapback traps, oil cards and burrow counts to give us a pretty accurate idea of what's going on in the paddocks that have been trapped for well over 20 odd years. So we've got quite a good data set for that region. The mouse chew cards and active burrow counts we do in northern New South Wales and 2 transects in the Callide and Dawson Valley in central Queensland. Burrow counts I do like because they give you a pretty good idea of whether mice are there or not. Chew cards, or oil cards, they're much more subjective, depends on what other food's available to the mice. There might be a heap of mice around, but they're not touching the cards because there's much more interesting and tasty food resources around. So there's also monitoring networks down here set up with key farmers and agronomists. They do it on a seasonal basis as well and feed all their information back into the central collection point in CSIRO. So just a pictorial show of where we've got all these monitoring sites right through the grain production areas in New South Wales, of Australia. Current situation in Queensland, I think mice reached the peak through December, January. They're still quite high, and there's isolated populations in the Dalby, Wonjeen, Jimbaugh and Cecil Plains areas where they're still hitting sorghum pretty hard. Based on the trapping results in December and early January that I got on the downs, the numbers seem to be increasing, and all the females were still pregnant and breeding and pumping out more into the population every 3 weeks. The dry summer has knocked a bit of the activity down, and assuming that we have rain between now and the winter crop sowing, there could continue to be damage, but if there's no rain there won't be too many winter crops, so that could solve the mice problem. Mice are still very high in South Australia. I'll be off down to South Australia in a couple of weeks to do some follow-up monitoring there to get an idea on their breeding status. It remains low everywhere else. As I said, food availability is an important food resource. If you can knock off the food through various methods, that reduces the potential for mice to continue to be a problem. Spilled grain is high on their list of preferred food from harvest operations or silo transfers around the silos and sheds. That needs to be cleaned up. Shelter is also a key requirement, and minimum till, stubble retention and reduced grazing has made that much more easy for the mice to get around and survive from season to season. We need to control weeds and volunteer plants before they set because they also provide an alternative food source. So in summary, the mouse abundance is likely to stay high on the Darling Downs, so that's a heads up to the growers out there who are planning a winter crop. Also, remain high in South Australia, which doesn't affect anybody much here. They're low in all the other regions. This is part of a 3-year project funded by the GRDC to develop much more accurate and regionally specific models for the growers to be told about. And at this stage, I'd like to thank all my colleagues in the CSIRO and Invasive Animals CRC, and to all the growers who give us regular access to their properties and keep us updated with information on crop yield and their farm management practices, so that our statisticians can try and integrate all that information into ongoing mice numbers and see if there's any relationship between farm management practices and mice numbers over the long term.
Just interested to know whether there's any data on the effectiveness of baiting after flowering or early grain fill. It seems that once guys have actually left it a bit late and made the call later on in the season, it seems like the control's very limited, and guys seem to be going back baiting sorghum up to 3 or 4 times, and you just don't seem to be able to pull them up. Do you have any data or any explanation on timing, whether we should be making the call early before we before flowering?
No, that's a question that's been asked, and by collecting all the farm management practice information on a seasonal basis from the growers, we're building up a background there to see if baiting is effective or more effective at particular times of the season. But at the moment we don't have that information. But by going through and talking to the farmers on a seasonal basis and picking their brains about what they've done, and even down to what varieties they've sown, what chemicals they've used, all that information is being collated, and we may be able to come up with some better ideas on when baiting is going to be most effective for reducing mice as well as cost effective for the growers.
Yeah, first of all, I think it's great to have that monitoring going on, because it keeps us a better idea what's going on, because it's good to hear what you say about those bait cards, because often we rely on them and, yeah, like you said, often they don't give us a clear picture, so it's great to have that monitoring going on. A couple of questions is, we have trying to get an area-wide management. If we've got a lot of fallow paddocks with mice holes in them, and we've had growers bait, but if their neighbour's not doing it, how far do they travel? Is there any benefit in one grower doing it to his farm, or is it a waste of time if all his neighbours aren't doing? And the second question is, on that issue on the bait, I was under the impression that mouse-off did have an attractant which made it quite attractive to eating it even with that other food source there. I was just wondering if you could comment on that or not.
Yeah, you can see mouse holes in fallow paddocks, but unless you go along and spread talc around them and have a look the next day, you're not sure whether they're active or not. The burrows will stay there as little holes in the ground, even though there's no mice around. And so you need to sort of check whether they're being used. The easiest way to do that is just, what I do is walk 100 metre by 1 metre transect, count all mark it out end to end, count all the burrows, spread talc around the holes, each hole, walk that same transect the next day to see if the talc has been disturbed, and that'll give you an idea of how many active burrows you've got rather than inactive burrows. And in terms of the bait, the attractant, I think, is one of the vegetable or seed oils, could be linseed oil, that's used to glue the zinc phosphide powder to the grain, and that's the attractant. Mice are attracted to any vegetable oil, but linseed oil has been found to be most palatable to them. Zinc phosphide itself is quite bitter to the human taste, but that doesn't mean it's bitter to mice. But it's the oil that's the attractant, and it also serves to glue the powder to the grain. A dominant male has a home range of around about the size of a tennis court, given adequate food resources in that area. But Judy Corley, who did a lot of mice work before I moved to Queensland, radio collared quite a few mice, and she'd found them up to 7 k's away after a week. So they travel a fair distance, if they're looking for food or being shoved out of territories by other dominant males, because it's a very male-dominant hierarchical society, and the young males get shunted away from existing territory, so that causes a wave of movement through the breeding season. And you're looking at around about $3 a hectare difference in bait price or baiting by air if you can get a few neighbours in. So that reduces the potential for re-invasion if they've got to travel further to get into your place if all the guys around you have baited as well.
Has there been any work on biological control at all in mice?
CSIRO did a lot of that up to about 15 or 20 years ago. There's a couple of immunocontraceptive methods that they looked hard at, but wasn't species specific enough. There's too much potential there for native rodents to be affected, and native rodents are definitely not a problem in any way, shape or form, so any potential for damaging native rodents was deemed unacceptable. So all that work stopped. I have an idea for a biological control agent at the moment. I'm looking for funding, and that's quite a few years down the track because it involves a lot of molecular work. But again, I'm still looking at the possibility that this bacterial agent will or will not affect native rodents, because if it affects native rodents, it's dead in the water right from the start.
How long do mice live in a moderately good season, and how long are females sexually active that they can pup for?
Mice in captivity can live 4 or 5 years because they live in a pretty well cared for environment, but out in the wild, 1 to 2 years is the general lifespan for mice, and females are sexually active and sexually mature from around about 6 weeks of age, and they continue to breed right up until death. They don't appear to have a menopause where breeding stops. So they keep pumping about at 6 or 7 per litre, and they can produce about 5 or 6 litres a year, all going well. So a breeding pair can produce 500 mice in 6 months, given very good environmental conditions and assuming no infant death. So all those 500 can contribute to the next population growth as well.
Well, just comment again, just that area-wide management thing is important. Like you said, we had people with like chickpeas that left them there, and they just bred the mice in there. And I think the other thing you might need to do, it'd be good to do some research. It was very noticeable once got those heat waves came, that the mice became very voracious. They were chasing moisture in those sorghum heads, that people have got to be preemptive, and I was preemptive in some instances, and other areas I got caught, I'd already baited, and another wave had come in from other areas where they hadn't been controlled or looked at, I guess. So I think it'd be interesting to sort of preempt a bit when these heat waves hit, because that's when they do a hell of a lot of damage from they're chasing moisture in heads, just not food.
Well, mice don't need free water if the food that they're eating contains more than 15% moisture. So they can survive quite happily without free water if they haven't got moisture in their food. And that's not entirely vegetation. As Melina said, they love insects, Heliothus, anything else, which are high moisture content. They'll chase moisture because they need the water, but they don't need free water to live unless their food source contains less than 15% moisture, in which case then they require 1 to 2 grams of free water per day, which is relatively easy to get just from early morning dew. If the growers see an increase in birds of prey, particularly the black-shouldered kites, that's always a indicator of increased mice, because that's their main dietary source.
If you had a really high load of mice, say 1,000 per hectare plus, does cultivation destroy burrows and therefore kill pups in the ground, or is that a waste of time?
If the burrows are close enough to the surface, it will. But I've tried to get farmers to cultivate their paddocks in the past, and it was sort of like, the worst possible thing I could ever suggest, and please get out the front door. But with the problems with chemical resistance in weeds, cultivation is becoming a bit more prevalent. But because the burrow systems have remained undisturbed for such a long time through conventional farming, conservation farming, they can be quite deep. So tillage isn't going to disturb a hell of a lot of them. And it's a fallacy that mice will drown in floods and heavy rain. The only ones that will drown are the babies in the burrows that are physically unable to move. Everything else is up the nearest grass stalk or bush or stem very quickly once the soil starts to swell.